Experimentally, it has been observed for a single crystal of a number of metals that the critical resolve shear stress, that is tau CRSS, is a function of dislocation density rho ds, this one. So this is the expression that is relating the critical resolve shear stress with the dislocation density. Okay, where tau naught and A are the constant. Okay, tau naught and A, these two are the constant. Okay, and for copper, the critical resolve shear stress is 0.69 megapascal at a dislocation density of 10 is to 4 inverse of mm square. Okay, if it is known that the value of tau naught for the copper is this much 0.069 megapascal, compute the critical resolve shear stress at a dislocation density of 10 is to 6. Okay, inverse of mm square. So basically, it is asking that we have to use this expression, that is the relation between the critical resolve shear stress and dislocation density, okay, for the single crystal of various metals, okay, and we have to find the tau CRSS value, that is the critical resolve shear stress value at a dislocation density of 10 is to 6 inverse of mm square. So let's do. What are the information we have? We'll just write here. We have critical resolve shear stress value tau CRSS, that is 0.69 megapascal at dislocation density of 10 is to 4, okay, inverse of millimeter square. Okay, next we have the value of tau naught, that is one of the constant in this equation, this relation, and that value is equal to 0.069 megapascal. Okay, now next we have to calculate the critical resolve shear stress, okay, at a dislocation density when the rho d is equal to 10 is to 6 inverse of mm square. Okay, so this value basically we have to calculate. Okay, this value at a dislocation density of this much. Okay, what is unknown to us? That is the value of constant A. This is unknown to us. So what we will do? Basically, we will put all the known values and we'll try to find the value of A. Okay. We have given the critical resolve shear stress value at 0.69 megapascal. Tau naught value is given as 0.069 megapascal plus A into square root of dislocation density, that is 10 is to 4. Okay, inverse of mm square. Now, if we find the value of A, we have to just put these values to the left hand side. Okay, this will be in megapascal, will be equal to A into 10 is to 2 mm inverse. So what is the value of A? It will be 0.69 minus 0.069 megapascal divided by 100 mm inverse. And if you just find the value, we will be getting 6.21 into 10 is to minus 3 megapascal into mm. Okay, so this is the value of, constant A. Now we have got the value of tau naught A and rho d value also we have. So we have to simply calculate the critical resolve shear stress when the dislocation density is this much. So we'll now solve very quickly. Now we can again write the expression tau CRSS will be equal to tau naught plus A square root of rho d. Okay, tau naught value is 0.069 megapascal. A value is 6.21 into 10 is to minus 3 megapascal into mm, and rho d is 10 is to 6 is inverse of mm square. If we just solve it, we'll be getting 0.069 megapascal plus 6.21 into 10 is to minus 3 MPa into mm into 10 is to 3 into mm inverse. This will be gone. So, and this will be gone. So it will be simply 0.069 megapascal plus 6.21 megapascal. Okay, and we have to simply add them together. We'll be getting 6.28 approximately. Yeah, that will be the final answer. So the critical resolve shear stress value is 6.28 megapascal when the dislocation density is 10 raised to 6. So in this question overall, what was given to us? We have given the critical resolve shear stress value when the dislocation density was 10 raised to 4 inverse of mm square, and we have given the value of tau naught, that is one of the constant of this expression. So we have calculated with the help of these values the another constant A, and then we have utilized these values of tau naught and A to find the critical resolve shear stress value at the dislocation density of this much. So this is 6.28 megapascal. So what we are concluding overall, when the dislocation density was 10 is to 4 inverse of mm square, the critical resolve shear stress was 0.69 megapascal, and when the dislocation density became 10 to 6 inverse of mm square, then the critical resolve shear stress increases to 6.28 megapascal. So critical resolve shear stress is increasing as the dislocation density is increasing. Thank you.